Hi folks, so this is question 5 and it's differentiation. So the first one, it just gives us a function and we just need to differentiate both terms separately. So x equals x squared minus 1 over x. So you could change 1 over x straight away just to make it a little bit easier to look at and to differentiate into minus x to the power of minus 1. Okay, that's just the rule of indices. When you put it back up over the line, the power becomes negative. So then it's easier, you just drop the power. First one's easy anyway, you just drop the power down, so it's just 2x, and then I multiply it by the power, and then the second one minus, okay, let's just do this in brackets. Now you just need to be really careful with the signs here because you can lose marks easily enough. We're going to drop down the power to a minus 2, but first we need to have multiplied the x by minus 1, so it'll be minus 1 x to the power of minus 2 here, and then that's almost it. Equals, and you can tidy up then because you've got 2x and then you've got minus multiplied by minus, so that's actually going to be plus, so it's going to be plus x to the power of minus 2. And then I don't think you need to, it doesn't really say what form to give it in, but you can change that down into 2x plus 1 over x squared if you want. So that's the final answer. But I think in that form there, I think that would get you the marks. Right. X plus 1 is a factor of f of x. Find the three values of x for which f of x equals 0. So when you see this x plus 1 is a factor, straight away that's a clue to divide it in. So we're going to divide it in, and then I reckon we're going to get a quadratic easily enough, and then hopefully we can solve that quadratic for the other two values. So x plus 1, let's divide it into, some people use a box method for this, so you can if you want. I'm going to do it this way. So x into 2x cubed will go 2x squared times, and then we're going to multiply, so 2x squared times x is 2x cubed, and 2x squared times 1 is 2x squared, so plus 2x squared. Then we're going to subtract from it, subtract both of them, so they'll cancel out, and then we're going to get minus 23 x squared here, and I'm going to bring down the 40x, so plus 40x, and then we're going to divide in again, so x into minus 23x squared will be minus 23x, and then multiply, so minus 23x times x is minus 23x squared, and minus 23x times 1 is minus 23x. So let's subtract them again, so we have to change the signs here, so that's going to be 63x, and then I'm going to bring down the plus 63, and I'm going to divide x in again, so then I get plus 63. 63 times x is 63x, and hopefully we get the same thing here, yeah, so plus 63. So just take them away from each other then, and they cancel out. So we're left with this quadratic, so 2x squared minus 23x plus 63 equals, and it's going to be equal to 0. Because the original function was equal to 0, and then we just basically divided in a factor of it. So I'm going to divide, there's different ways again you can factorize this. I'm going to do it this way. So you can go and you can split up the middle term, and there's a box way of doing it. there's loads of different ways of factorising, so you just need to factorise that quadratic whatever way you know how. So I'm going to do it this way again, so it'll be yeah, so it's going to be 7 down here and 9 up there, and then they're both going to be minuses. So if you double check, then minus 9 multiplied by minus 7 will give you plus 63, which is what we want. And if you do 2x times by minus 7 first, that's minus 14x, and then take away another 9x, will be minus 23x. So that's what we want as well. So that's our factors found. So our two sets of brackets are 2x minus 9 and x minus 7. So therefore we've got two more solutions then. So either 2x minus 9 equals 0 or x minus 7 equals 0. So 2x equals 9 if you move the 9 across, and then x equals 9 over 2. Or the other case, x equals 7. So x equals 9 over 2, x equals 7 are two of the solutions, and if you go back to the start here, the other factor was x plus 1. So x plus 1 basically equals 0, so therefore x equals minus 1. And you should kind of know anyway, if x plus 1 is a factor, well then x minus 1 will divide in. So those are our three values for x: minus 1, 9 over 2, and 7. So that's the first part of B. Right, find the range of the range of values for x for which f dash x is negative, correct, to 2 decimal places. So for which that's negative. Right, so f of x anyway is 2x cubed minus 21x squared. Plus 40x plus 63. So that's f of x. So we need to differentiate first anyway. That'll be some of the marks. So this will go to 3x squared. So you drop, oh sorry, it won't. So you multiply, so 6x squared, you drop down the power of x, minus, and then do 2 multiplied by 21, so that's 42. And the x squared drops down to just an x, and then 40, and then the 63 will be gone. So that's our so that's f dash x then. So we want all of that to be less than 0. Less than 0. So for which f dash x is negative. So if it's negative, then all of that thing has to be less than 0. Clue in the question here then, it says correct to 2 decimal places. If it's correct to 2 decimal places, we're not going to factorize it, because decimal places always means that you get that, well, you obviously get decimal answers, but it means that you use the minus b formula. So we're just going to use that formula, minus b plus or minus root b squared minus 4ac over 2a. So you should be used to that formula, and it should be in your log tables anyway. So minus b, so we're going to have 42 plus or minus minus 42 squared minus 4 times by what a is. So a is 6 times c is 40. All over 2 times 6. I just noticed all of those numbers were even in the, so I could have simplified down that quadratic before I put them into the formula, but it shouldn't matter. You just need to use calculator anyway. So I'm getting 804 in there over 12, and then we're going to get two values for x. So 42 plus root 804 over 12, or 42 minus root 804 over 12. So the plus option is 5.86 and the negative is 1.13. Sorry, it'll actually be 1.14 when you round it off. So these are just two values you've gotten then. So if you look back at the question, then the tricky bit is, so it says find the range of values of x for which that is negative. Okay, so the range of values of x. So if you think about it, it's a quadratic where the x squared term is positive. So if you were to look at it on a graph, really what you need to work out is is the range of values in between those numbers, or is it outside of them? So is it both sides of those numbers, if that makes sense? So if you're thinking about it on a graph, the roots of it are 1.14, so we'll just say that's 1.14 there roughly, and then out here would be 5.86. So the curve will look something like this, because it's a quadratic. So therefore we're interested in where it's negative, so where the curve is negative. Therefore whenever the curve is negative, it has to be down below the line, doesn't it? It has to be down here. So the y values would all be negative down there. So therefore it's in between those numbers. So that's going to be the range of values then. So you can write it like this. And that's that question.